Grade 11 pre-cal, lesson 16, quadratic functions. So this is our first introduction to quadratic functions. You've seen some of this before in the previous grade when we talked about trinomials. In the previous grades, you would graph linear equations. Well, now what we're going to do is we're going to graph stuff with squares, and that's what makes it a quadratic. So basic formula here, here's a bunch of values of x, -4, -3, -2, -1, all the way up to positive. And then all we're going to do is some squaring them. So like if you're trying to find the area of the square up here. So -4 squared, positive 16. Now, if you notice, the whole bottom row is positive. Whether you square a negative or square a positive, you end up with a positive. So what we have is it's a function basically, right? We have a set of ordered pairs. So there's the x value, right? Like -4, the y value that goes with it is 16. Another x value is -3 and 9, right? And we could graph those and graph those and graph those. Okay, so now when we're dealing with that, we can talk about domain and range. Now, domain and range, how do you remember? Well, just remember your alphabet. X comes before y, D comes before R. So domain and range. So what we're talking about here is the domain is we want to talk about all the different x values. So in this case, pretend that the x values go on forever, like -5, -6, -7, that way. And pretend they go on this way, positive 5, 6, 7, and they go on. So basically we're talking about -infinity to positive infinity. And there's two ways of writing it. This is interval notation. You might have learned this. And when we're talking about infinity, we use round brackets. You can also basically do a variation on set notation, which is x is an element of R. So what that means is it's saying x is all real numbers. And that makes sense, right? Because when we're dealing with this, we could have, -3.5 and -3.6. We can have everything in between those points. So set notation, interval notation. I'll probably do most of them in class because that's the easiest way to do that. Now, range is all the y values. So if you look at this, the lowest y value is a 0. Sorry, 0, I'm looking around here, and then everything else is greater than. So there's one of two ways of doing this. You could say, okay, yeah, it goes at 0 and it includes 0. That's why we have to put the square bracket on interval notation. Or you could say y is greater than or equal to 0. So it's everything larger than that one. So that would be your range in this case. So domain x, range y. Now, flip the page, let's graph this thing. So if you graph all these points, you would do 0, 0 as your origin, right? And then 1, 1, 2, 4, 3, 9, and we can keep going, right? 4, 16, 5, 25. And then we have all the negative values right here. So -1, 1, -2, 4, -3, 9, and keep going off. And now what you get is you fill in the shape, and it's not a nice straight line, it's a nice curved line, and this is called a parabola. So you can have parabolas that open up, that open down, they're shifted left and right, and shifted up and down, and are wider and narrow. We're going to talk about those in the next lessons. But for now, we want to talk about some key features of this parabola. The first one is the vertex. The vertex is where it changes direction. So if it's coming down this way and then going back up, the vertex in this case is 0, 0, your x and y coordinates. So your vertex, 0, 0. Now, you can also then talk about, does it open up or down? This one opens up. You can also talk about whether it has a minimum or a maximum value. It's easy. This is a valley, which is a minimum. And if it was the other way, like if it was raised up here, it would be like a mountain, and the person that lives on the mountain is max. So the one easy way is if it goes this way, you have a maximum. Now, if you know the vertex, then you know two things. You know whether it's the min or the max, right? And you know the axis of symmetry, right? So, well, let's do the min or max. In this case, yeah, we'll do the min or max first. In this case, you look at the y value. So what you would say then, and so we actually drew this out here, let me get rid of the highlighter here, and you would go, it's a minimum in this case, and you'd put y equals 0. And all it is, it's the y value of the vertex. So it's that one right there, right? And then if you talk about the axis of symmetry, symmetry is how it's reflected left and right. It's like a reflection in the mirror. And if you know the vertex, you just look at the x value, and that tells you the axis of symmetry. And then in this case, it's the form of x equals 0. So for instance, if you had 2, 3 up here as the vertex, 2, 3, right? Your axis of symmetry would be x equals 2, and whether it's a min or a max would be y equals 3. So if you know the vertex, you know the other pieces of information. Okay. And this is just the rest of the thing. So the vertex is 0, 0, right? Axis of symmetry is x, and we know what the minimum is in this case. So when you're looking at functions, they normally come in the form of f of x or y equals ax squared plus bx plus c. And this is from like last year when we did trinomials, right? And then we factored them into two binomials. What I want to know here is you can look at the zeros, right? Zeros are x-intercepts. Basically, where does it cross, or how many times does it cross the x-axis? So in this case, you look back up here and you go, okay, it goes down, it touches the x-axis, so that technically crosses it. So in this example, we have 1, 0 at 0, 0, right? That's the point that it actually is. So there's 1, 0 in this area of function, and it is at 0. Now, in the future, when we look at this, you're going to have either 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. And we'll talk about that in the upcoming lessons. But this is just your basic introduction of what a parabola is, what a quadratic is. And that's the basic function. Get used to graphing this 0, 0, 1, 1, 2, 4, 3, 9, and then a reflection over this axis. Get used to graphing that. We are going to do tons of that.